First, I'd like to ask the reporter. As I have the first time, I'd like to ask to answer this yes or no. Is humidity important for your problem? Humidity of the air?
To a very small extent, but yes.
Yeah, that is important. Okay. The pollen debris or not?
Oh, sorry, what was your question?
If the humidity is important for the problem.
Yeah, I think that is a relevant part.
Okay, thanks. And what about the area? You said that the surface area is not important. You actually
The surface area is important.
Okay.
The bigger the surface area, the bigger the losses are.
Okay, so if the area is important, there is some dissipative force, yes or no? This dissipative force doesn't depend on the shape.
Dissipative force?
Yeah.
Like even drag force?
Yeah.
Yes, of course. That depends on the shape.
So the shape is important.
Yes, of course.
Okay, so okay. Isn't it spherical, perfectly spherical, as considered actually possible to reproduce in the experiment?
Whether it is possible to
reproduce experimentally
for this complete spherical object? No.
Okay.
And in the beginning, that was the best possible theoretical model.
Okay. And how do you control the constant rate of heating?
Constant.
You said that the rate of heating was constant. Do you actually repeat that the rate of heating is constant for the light?
The rate of heating by the solid fuel, yes, yeah. It was constant.
So what about the initial heating time while the lantern is for? Is it important because
yes,
you consider that?
Yes, the simulation considers the heating time. It calculates what is the optimal heating time to flow that.
So there is a variation of the heating time.
Yeah.
So the power is not constant.
This is the best heating time we found.
Okay, so the power is not constant.
The power output is constant, but the time when the lantern is about the light is not constant. It depends.
What promotes the increasing of the mechanical energy in your system as you should?
What?
The increasing mechanical energy
the energy is increased by the power input of the light and decreased by the losses.
Okay, what about the convections inside the lantern? Do you think it's
Convection is counted for in the bottom area. Yes, for the bottom area, that is.
Okay, the opponent agrees that is important.
I agree it is important.
And briefly, why?
I don't really know, to be honest.
Thank you. Summary of their explanation. They draw a force diagram, the power source of the candle, they talk about it, and they talk about the ideal cases for approximation. In the experiment, they vary the volume and different candles, modifying the task. And in conclusion, they get the better model in their conditions. And there is no clear comparison with their theoretical model and their experiments. The positive points of that, they draw a force diagram, although they didn't consider like if the drag force is the aerodynamic important, also the shape. There's approximation to the ideal cases, which is a good approximation for the case of the lantern. They evaluated the model and the loss of heat, and they plot some graphics. Although they saw that there was one with no fit, while actually there was a clear tendency of the points to follow. The negative point, they did not use the single T-light, which was really explained in the task of the problem. Use a single T-light. And please just make some conclusion about it. The constant rates of heat in the task too, we don't agree that the rate of heating was constant actually, because the task asks you to consider the initial heating time while the lantern hasn't takeoff. So the aerodynamics is important for the problem in your opinion, and they said that the shape was not important, but it actually is implicit in the drag force. The initial heating time, the convection inside the lantern, so you have some you don't have an equal distribution inside the lantern of heat. The humidity, they didn't consider that. The external temperature and pressure, the graphic with no fit, while tendency is really clear in the graphic. There is no clear comparison with their mathematical model that they showed for the ideal cases and the best model that that got and what is the optimum point of that. They modified the task, but they didn't actually conclude it. What was going to happen whether a T light was used instead of the light that they used it. And there's no variation of the combustible, and we think that the heating rate would be changed. About the opponent, the yes about material, the thickness would influence the loss of the heat, which we think it is important. The resistance of air, they mentioned that was missing in the presentation. The dissipative force, of course, the resistance of air, and they noticed that the reporter was pulling the lantern in the video, and so we do think that some lateral oscillations that they haven't analyzed could influence, as the video was showing. They did not notice, however, they did not notice the lack of the humidity evaluation, the combustibles, the initial time of heating, the lateral oscillations, the convection, so the distribution, the constant rate that they showed there, that we don't agree with that, and they didn't question the reporter. So in a general view of the discussion, they discussed about the thickness, they discussed about the video that they were pulling, no discussion about the link with the theory and experiments, no discussion about what happens with the T-light, that was the ask of the problem. And some parameters that are important that I mentioned before were not discussed. So thank you for your attention.
Reporting in 2 minutes.